and welcome to our first video in Module 3. In this video, we're going to talk about measures of center for raw data. What that means is we're going to talk about different ways that you can describe what is average or typical about a data set. So let's get started. Alright, so let's start out with the definition. So think about when you get a grade in a class. What your teacher is attempting to do is to take all of your work from the entire course and give you just one value to summarize that information. So the average grade that you receive in a class should somehow incorporate all of the work you did the entire course. So instead of using that word average, we're going to call this a measure of center. So we're going to use the phrase measure of center to basically mean an average or a typical value of your data set. In this video, we're going to discuss 4 different measures of center. So let's get started on the one you're probably most familiar with. The first measure of center is called the mean. The mean is found by adding together all of the values in your data set, and then you divide by how many numbers there were. Before we do an example of finding the mean, let's talk a little bit about notation so we can become familiar with what this formula looks like and what the formula means. First, we're going to use the letter X to represent a data value. So just sort of in general, X is going to be a piece of our data. Now to find the mean, we want to indicate that we're going to add all the data together. So we're going to use this notation to do that. Now this pointy E looking thing that's in front of the X is actually a Greek letter. It's a capital letter called sigma. So whenever you see sigma X, that's going to mean we're going to add together all the things. Next, to find the mean, we're going to have to divide by the number of numbers. So we will use a lowercase n to represent how many numbers there are. If we're dealing with a sample, this is going to be the sample size, and if it's a population, it'll be the population size. So n just represents the number of numbers. Now, speaking of sample or population, we will sometimes be dealing with statistics, sample values, and other times we'll be dealing with parameters, population values. When we're dealing with a sample mean, we're going to use an X with a line over it, and we'll pronounce this as X bar. So X bar means the sample mean. To represent the population mean, we're going to use this symbol. This symbol, like sigma, is a letter of the Greek alphabet, and it is a lowercase mu. It's the Greek letter that cats would say, mew. And mu is going to represent our population mean. Alright, so let's use this notation in a couple of formulas. So the formulas for the mean are going to be, for the sample mean, you take all the things, add them up, and divide by however many there are. For the population mean, it's the same thing. So whether we're using an X bar or a mu, the action, the thing we're going to do, is exactly the same. I wouldn't worry so much about whether you should be using an X bar or a mu right now. It'll be pretty clear from context which letter we should be using. Later on, we'll be seeing the use of these 2 different symbols much more. Alright, so with the notation and the formulas under our belts, let's go do an example. Here we have 5 quiz grades for 3 different students, Alice, Bob, and Charlie. And we've been asked to find the mean quiz grade for each of these students. As we work through this problem, I'm going to show you 3 different ways that you can show your work. You may want to check with your teacher to make sure that you are showing the work that your teacher expects from you. Let's start out with Alice. In order to find Alice's mean, we first have to write down our formula, which is sigma x over n. Remember that the sigma just means add all the x's together. So that's what we're going to write out first. So first, we're going to write out all of Alice's quiz grades, her 2 100s, the 93, the 97, and the 94. Notice if there are repeats, you have to repeat them. So we're just going to take every single quiz grade that she got, and then we're going to divide that by the number of quizzes there are. Since there are 5 quizzes, we're going to divide by 5. Next, what I did was I went to my calculator and I just typed in 100 plus 100 plus 93 plus 97 plus 94. And that gave me 484. And we're going to divide that by 5. And when we divide it, I got a 96.8. So the mean quiz grade for Alice is a 96.8. Now, before we move on, this amount of work is what I would consider to be a full amount of work. This is more than you need to write. It's more than sufficient, and it shows everything that you did in order to get your answer. All right, now let's find the mean quiz grade for Bob. We're going to follow the same steps that we did for Alice. So for Bob, we're going to take all of his quiz grades, add them up, and divide by however many there are. So I'm going to write down 88 plus 88 plus 93 plus 77 plus 77. And we're still going to divide by 5 because there are still 5 quizzes. Now, in this case, I am showing my work of adding everything up and dividing by however many there are. So I'm just going to go ahead and type this whole thing into my calculator and get my final answer. However, I have to be careful when I do that. One way that I might try to type this into my calculator is like this. And this is a common way that students often get an incorrect answer. So let's see why this is incorrect. So if I'm a calculator, I've got the order of operations built into me, and so I'm going to follow them no matter what you type in. In this case, I notice that there's some adding and dividing going on, so I have to do the dividing first. So the first thing your calculator is going to do is divide 77 by 5, and then it's going to interpret it as a 15.4. Then it'll add all of those quiz grades together and get a 361.4. Now, this is a very weird mean because Bob's grades weren't anywhere near a 361.4. Remember, the mean is supposed to represent sort of a typical value or what you might expect. So we can tell that this answer is wrong because it's completely unreasonable. It's nowhere near the 77s or the 88 or the 93 that Bob got on his quizzes. So to avoid this error, if I want to type this into my calculator in one go, I have to put parentheses around that numerator. So when I type this into my calculator, I'm going to type a parentheses 88 plus 88 plus 93 plus 77 plus 77, close the parentheses, and then divide by 5. And when I do that, I wind up with an 84.6. This would be another acceptable way of showing your work. Alright, and now let's find the mean quiz grade for Charlie. We're going to start out the same way by jotting down our formula. But this time, to show our work, we're not going to write out that big long addition sequence. We're just going to type it into the calculator and write the resulting sum down. So on my calculator, I'm going to type 0 plus 81 plus 88 plus 61 plus 75 equals, and when I did that, I got 305. So 305 is the top part. There are still 5 quiz grades, so I'm still going to divide by 5. Next to my calculator, I'm going to do that division, and I end up with a 61. So Charlie's mean quiz grade is a 61. Now, again, this sort of work is acceptable in my classes. You might want to check with your teacher to see whether or not they want you to write down that whole big long addition, or if they'll be happy with writing the sum just on top like we did here. Now, before we move on, I want to point out, if I look at Charlie's quiz grades, his mean was a 61, which is what he got on quiz 4, but other than quiz 1, that was his lowest quiz grade. He did do pretty well on quizzes 2 and 3, so that 61 seems to be kind of low. Now let's look at Charlie's mean for a minute. The mean is supposed to represent sort of what is typical, right? What is an average kind of expectation. And Charlie did pretty well on quizzes 2 and 3. He got in the 80s, and yet his mean is pretty low. He got a 61. This is because his first quiz grade was a 0, so that 0 seems to be very different from those 80s and the 81. And whenever you have a value in your data set that's pretty different from the rest of the values, we're going to give that a special name. So whenever you have a data value that's significantly different from the rest of the data, we're going to call that an outlier. It lies outside of the expected range of data values. So in Charlie's case, I would say that his quiz grade of a 0 is an outlier because it's very different from the other quiz grades that he received. One of the questions that statisticians ask is, do these weird numbers, do these outliers, have an impact on our summary results? So If the value of a measure does not change in a significant way, whether or not you include the outlier, then we're going to say that measure is resistant to outliers. In other words, if a measure is resistant to outliers, then whether you include the outlier in your analysis or not, it's not going to change that summary value too much. So let's see whether or not Charlie's grade of a 0, that outlier, had a big impact on his mean or not. Alright, so suppose Charlie missed his first quiz because he registered late for class, and so the teacher figures this shouldn't be counted towards the grade. Let's figure out Charlie's new mean quiz grade for the class. In this case, when we added all the values up, because 0 was included, whether we remove it or not, it's not going to change the sum total. So when we go to readjust this mean, it's still going to be a 305 on top. However, this time there are only 4 quizzes, so we're going to be dividing by a 4 instead of 5. When we divide 305 by 4, we end up getting 76.25. So when we included the 0, Charlie's mean quiz grade was a 61, and now when we don't include the 0, it's a 76.25. And this seems to be a substantial difference, right? That's more than a letter grade. That's like a letter grade and a half here. So the outlier had a big impact on Charlie's mean. And this is going to be true in general. So generally speaking, broadly speaking, the mean is not resistant to outliers. This means that if you have an outlier in your data set, it can have a big impact on the mean. So depending on the type of data you're looking at, you may or may not want to include outliers in your analysis. In other words, if you want the outliers to be represented in your summary value, then the mean is a good measure to use. But if you don't want outliers represented in your summary value, then we're going to have to find a different way of measuring what is typical in a data set. So let's look at a second measure of center. The median of a data set is the value that's in the middle when the data are listed in order from least to greatest. Now, if you think of that word median, I always think of a highway, because the median is that part in the middle that's dividing the 2 different lanes. So the median is a value that's in the middle of a data set. Now, there are a few steps that we have to follow in order to find the median. So, here are the steps. First, you need to make sure that your numbers are lined up from smallest to largest. Now, this step often gets overlooked, in part because usually a big data set's going to be given to you in order, so you don't have to rearrange it, but that's not always the case. So before you go to find a median, first make sure everything is in order from the smallest to the largest value. Second, if your sample size is odd, that means there's going to be one number in the middle, so you just take the middle number. Here's what that would look like, right? So here I have 7 bunnies. That's an odd number of bunnies. So there's one bunny in the middle. So that's the value that I would take. But if the sample size is even, now there's not just one value in the middle. Now there are 2. So instead of reporting both of those values, we're going to take the mean of those middle 2 numbers. So if you have an even number of numbers, to find the median, you take the mean of the middle 2 numbers. Let's look at an example of this. Alright, so we're back to the quiz grades for Alice, Bob, and Charlie, and this time, instead of finding the mean, we're going to find the median for all 3 students. Also, we're going to find the median for Charlie both with and without that outlier of quiz 1. This is going to help us see whether or not outliers have a big influence on the median. So let's start out with Alice. To find the median for Alice, we're going to line up all of her quiz grades from smallest to largest. So her smallest quiz grade was a 93, followed by a 94, a 97, and then we're going to write down both of her 100s. So just like with the mean, if we have repeated values, we need to include each instance of the number. Next, I like to work my way towards the middle, one at a time, so I'm going to start on both ends and then move one spot over until I get to the middle value. Since we had an odd number of numbers, Alice's median is going to be this 97. And that's it. So if you want to, you could pause the video here and go ahead and find the median for Bob and for Charlie. and then you can unpause the video and we'll work through them together, see if you got it right. Alright, so let's find the median for Bob. Once again, we're going to line his quiz grades up from smallest to largest. So Bob has 2 77s, followed by 2 88s, and then concluding with a 93. We're going to work our way to the middle one at a time, and we find that the 88 is in the middle. So Bob's median quiz grade is an 88. Alright, so let's find the median for Charlie. First, we're going to find Charlie's median quiz grade by including that 0. So with that 0, we line these up from least to greatest. We've got a 0, 61, a 75, an 81, and an 88. We're going to work our way towards the middle. Ta-da! A 75. So including quiz 1, Charlie's median quiz grade is a 75. Now suppose we don't want to include quiz 1. Well, this time when we list our values, we're just going to drop off that 0. So we're going to include a 61, the 75, the 81, and the 88. And we're going to work our way towards the center again. But this time there are 2 numbers there. Because we only had 4 quizzes, we had an even number of quizzes, so we end up with 2 values in the middle. To find the median, that means we're going to find the mean of these middle 2 numbers. In other words, we're going to add 75 plus an 81 and then divide it by 2. When we do that, we end up with a 78. So if we do not include his first quiz, Charlie will have a median of 78. Alright, so let's compare those 2 values. Is the median resistant to outliers? Did Charlie's median quiz grade change substantially whether or not we included the 0? I don't think so, not too much. A 75 and a 78 are pretty close. They're nearly the same thing. So whether or not we included the 0 didn't really have a big impact on the median. So in other words, is the median resistant to outliers? Yes, there was not a big difference whether or not we included it. And this makes sense because the median is dealing with values that are in the middle of a data set, not with the endpoints, not with extreme values. So whether you remove one of the endpoints or not should not change what's going on in the middle too much. Now, especially if your data set is not put into order, the median could take some time to figure out. And the mean, as we saw before, also takes some time to figure out because there's a lot of adding and then you have to divide, especially if your data set's pretty large. So suppose we wanted just a real snap, quick way of finding a measure of center. That brings us to our third measure of center, the midrange. Now the midrange is the value that is halfway between the smallest and the largest value of your data set. In other words, the formula for the midrange is going to be add together your biggest value and your smallest value, and then divide that answer by 2. Because you only have to find the biggest number in your data set and the smallest one, this measure of center tends to be pretty quick to find. So let's do an example. Here we're going to find the midrange for each of the 3 students yet once again, and also again we're going to find the midrange for Charlie both with and without that 0. So for Alice, the largest quiz grade that Alice got was 100, and the smallest was a 93. So we're going to add those quiz grades together and divide our answer by 2. Remember to use parentheses in your calculator for the top, and we end up getting a 96.5. For Bob's midrange, his highest value was a 93, and his lowest value was a 77. So same thing, we're going to add them up, and then we'll divide our answer by 2. When I did this, I got an 85. So Bob's midrange is an 85. For Charlie, when we include the 0, his largest is an 88, and that 0 is his lowest quiz grade. So we'll do an 88 plus a 0, divide it by 2, and now we get a 44. And this is the worst measure of center so far for Charlie with that 0. So let's see what his midrange is going to be without the 0. So this time the high value is still an 88, but now instead of a 0, the lowest value is a 61. So we're going to add 88 and 61, then divide our answer by 2, and we end up getting a 74.5. So when we find the midrange, did that outlier have a big impact? Absolutely. Charlie moved from a 44 all the way up to a 74.5 just by excluding the 0. Is the mid-range resistant to outliers? No way. There is a huge difference whether or not we include the outliers when we find the mid-range. And this is because the mid-range deals precisely with extreme values. It only deals with the highest and it only deals with the lowest, which is where your outliers are going to occur. Now let's talk about one other fairly quick measure of center that we could find. Our fourth measure of center is called the mode. So the mode of a data set is the value that occurs most frequently. Now, you can get some weird stuff happening with your mode. For example, a data set might have one mode exactly, or it could have more than one mode if there's a tie, and you might even have no mode to your data set. So let's see how this might happen. Once again, we have our three students, Alice, Bob, and Charlie, and we're going to find the mode for each student. So for Alice, I'm going to look at her quiz grades and see if there's any that repeats more often than any others. And it looks like Alice scored 100 on both quiz 1 and quiz 2. So 100 repeats more often than any other values in Alice's data set, so her mode would be 100. Next, we're going to do the same thing for Bob. But I noticed something a little bit weird for Bob's quizzes. He got 2 88s, but he also got 2 77s. So this is an instance where we have two modes. We have a 77 and we have an 88. Now, just a comment here, you could list the modes as 88 and 77. They don't have to be in order from smallest to greatest. That's just my tendency. And now let's find Charlie's mode. Well, if I look at the quiz grades for Charlie, none of them repeat. So Charlie doesn't have a mode. There's no mode quiz grade for Charlie. So here we're seeing one of the problems with a mode. If I was going to use the mode as a grade to put on a report card, Alice is happy, she gets 100. But now Bob has two letter grades. He has a 77 and an 88. And this might be a C and a B, so which one does Bob get? And Charlie, poor Charlie, doesn't even get a grade for the class because he didn't have a mode that repeated. So here we can see one of the problems with a mode. However, the mode was fairly easy to find. Okay, so let's summarize some of this information that we've just been talking about. First, although the word average is generally used to mean the mean, right? When we hear the word average, we usually think add everything up and divide by however many things there are. So although that word is usually used to mean the mean, it could actually mean any of the measures of center that we talked about. So because of this, we're going to try not to use that word average because we want to avoid confusion. Second, we found that the mean and the mid-range are not resistant to outliers. So if you want extreme values to be represented in your summary value, then the mean and the mid-range would be appropriate measures for you to use. However, number 3, the median and the mode are usually more resistant to outliers. So if you think the outliers are errors, or you just don't want to include the outliers in your summary value, then these would be more appropriate measures of center for you to use. 4, the mode and the mid-range are really good measures of center if all you want is a real quick value, just a fast estimate, because they're pretty easy to find and pretty quick to find. And lastly, number 5, of the 4 measures of center that we discussed, only the mode can really be used if you have qualitative data as well as quantitative. So for example, if I wanted to describe the average eye color, I can't just add all the eye colors up and divide by however many there are, or take the lightest eyes and the darkest eyes and divide them by 2, right? So that doesn't really make sense. Most of the measures of center we talked about require the values to be numerical. However, for the mode, I could say the most popular eye color is brown or hazel or whatever. So the mode is useful for qualitative data. This concludes our video about measures of center for raw data. If you'd like to go back to Module 2 and watch our video about misleading graphs, you can click on the arrow to the left. In our next video, we'll be discussing measures of center again, but this time for data that's been grouped together. So for example, instead of giving you a list of quiz grades for the different students, maybe there's a histogram showing quiz grades, or there's a bar graph, or something like that. So in the next video, we're going to talk about how you can find the mean, the median, the mode, and the mid-range for data that's been grouped together somehow. As always, thanks for watching, and have a wonderful day.